Hi there. Okay, here's a practical I'd like to carry out over the half term. Have you ever been making a cup of tea and thought, I wonder if I can calculate exactly how long it's going to take for that kettle to boil? Well, wonder no more, because with a nice little bit of physics, tiny bit of rearranging, you can do just that and amaze everyone in your house with it. Okay, so this is a specific heat capacity experiment. So we're going to need the specific heat capacity equation. So this is what we've got. Our change in energy is equal to the mass of our substance times its specific heat capacity times the change in temperature. Now, I know the AQA syllabus for GCSEs has this as a delta theta symbol for a change in temperature. I'm so used to writing it that way, I'm just going to carry on writing it like that, okay? So let's talk about the variables we know first. And remember, we're going to calculate exactly how long it's going to take to boil this kettle. So, M, mass of our water. Back when we were looking at densities, we said that the density of water was 1,000 kilograms per cubic meter. So that means that if you've got 1 litre of water inside your kettle, that's going to have a mass of 1 kilogram. So we're going to have a mass 1 kilogram. The specific heat capacity of water is approximately 4,200 joules per kilogram. 4,200 joules per kilogram degrees C, joules per kilogram degrees C. What does that mean? Well, that means you need to put 4,200 joules of energy into 1 kilogram of water to raise its temperature by 1 degree. And we're going to be raising it quite a bit more than that. How about our change in temperature? If you don't have a thermometer to find the start temperature of your water, then we'll just make an approximation. I'm going to say that the water coming out of your taps is around 15 degrees, and we're going to say that your kettle's going to switch off at 100 degrees. So if we want the change in temperature, remember that's final minus initial, so it's 100 minus the 15, so we've got 85 degrees C for that. Okay? Right, how about the energy? Remember, we're trying to find out exactly how long it's going to take to boil, but we've got energy. There's no time in this. Okay, so get your electric kettle, because you're going to need an electric kettle for this one. And on the bottom of your electric kettle, if you have a look, there should be a sticker. And can you see the power rating there is 2,500 to 3,000 watts. So power, let's go somewhere in the middle. Let's go 2,750 watts for my kettle. 2,750 watts. So how are we going to get this into our equation? Well, if you remember, energy is power times time. So I can rewrite this equation. Power times time equals MC, change in temperature. Okay, so now we've got our time. Now we're going to need to rearrange this. So this is quite an easy one to rearrange, because look, we just don't want the P on this side of the equation. We need to put it on the other side. And because it's times, then we need to divide it. And whatever you do to one side of the equation, you have to do to the other. So if I'm dividing by P, I have to divide the other side by P. Well, P divided by P is just 1. So I can get rid of all of that. So there is my final equation. That's how I'm going to calculate my time taken to boil this kettle of water. So do this bit first. Do this bit first. Find out your time. Remember, that time is going to be in seconds. So if you get something like 85 on there, you're looking that that's going to take 1 minute and 25 seconds. Okay, and then you can start your stopwatch, start your kettle, and then just see exactly how close you can get to this, and amaze everyone in your house with your amazing skill at physics. Okay, so good luck with this one. Stay safe, people. I hope to see you soon. Let me know how close you get to this. Okay, send me a quick message when you've done it and let me know exactly what your calculation was, and tell me how amazed people were. Okay, good luck.